All right, the first problem of this set, the 2021 AMC 10A, problem number 11. By the way, if you guys don't have notifications on, turn them on so that you can get these videos on your feed faster and you know where to find them. For which of the following integers b is the base b number, this 2021 minus 221b, not divisible by 3. Be careful, it's not divisible by 3. So, how are we going to do this? Well, a basic understanding of number theory, how it works with different bases, which is not that common if you haven't, done maybe intro to number theory or at least watched some Khan Academy videos about different bases or had a computer science class, those kinds of things. But it's not going to take much, right? Don't try to think of this like this. Do you always think in a different base? Probably not. So let's get rid of the base b part of it. How do we do that exactly? Well, let's talk about something like 741 in base 10. We don't write the base 10, but you could if you wanted to. It's just redundant. It's just assumed to be base 10 otherwise. Kind of like we don't write 741 over 1. So this would be 7 times 10 squared plus 4 times 10 to the first plus 1 times 10 to the 0. 741, the base squared, the base to the first, the base to the 0. When you first do this, when I first did it, man, I was not that fast. Like, it took a while. You get faster the more you do it. That's why you want to do it more often. So let's do this one here now. This would be b to the 0, b to the first, b to the second, b to the third. So you're going to have 2b to the third from here, and then 0b squared, 2b, so plus 2b plus 1, okay? And then, because it's 1 times b to the 0, which is just 1. And then this would be minus, and this is the b to the 0, b to the first, b to the second. It's 2b squared. And it's the whole expression, right? So we're going to distribute that minus to all three parts. So minus another 2b and then minus 1. So the plus 1, minus 1 cancel. We like that. The 2b and negative 2b cancel. We like that also. And what we have left is 2b cubed minus 2b squared. Okay, let's go back and see what we're trying to do. We want to know for which of the following integers b is this number, which is now written in base 10, not divisible by 3. Okay, well, you could plug in right now with the answers, but let's go ahead. I see 2 and a b. Let's pull out 2 times b squared, and then it would be b minus 1. That might be easier to think about, in my opinion. Obviously, if you plug in 3, they're both going to be divisible by b from this one. So there's no point in doing that. If you plug in 4, 4 minus 1 is 3, so that's going to be 3 times something, so that's not it. So it's not b, it's not a. If we plug in 6, 6 again is a multiple of 3 by itself. So because this would be, we now know that it is a 1940s German soldier. It's not C. Okay, then D, 7. So we're going to plug in 7 now. 7 minus 1 is 6. 6 is a multiple of 3. The whole thing's a multiple of 3. This is why it's better to factor, because it gives you kind of some advantages in your thinking processes. Imagine plugging in 7 into here and 7 cubed and stuff like that. All right, last one. We better hope it works. It's E if it works. So you're going to have 8 minus 1 is 7, and 2 times, this is a power of 2. So I've got a power of 2 times a 7. There's no 3's in there. So since there's no 3's, we can definitely be assured that it's 8. Let's get to number 12. All right, so here we are in the 2021 AMC 10A. It's problem 12. If you're on the 12A, it's the last problem of your rapid fire set. 2 right circular cones facing down as shown in the figure. Sorry about the drawing skills. Below contain the same amount of liquid. Okay, so in other words, the volume of the liquid cone, if you will, is equal. We don't have to know the cone itself, but the volume of water inside is also a cone, and those volumes of water will be equal. The radii of the tops of the liquid surfaces are 3 and 6, so 3 here, 6 right here. Into each cone, let's just pause right there. Let's figure out some more information before we read any farther. If the volume of a cone is 1/3 pi r squared h, so then for us, the volume of the first cone will equal 1/3 pi, our r is 3. And so we'll have 3 squared, and I will call that h2, I guess. And then, yeah, or H1, we're doing H1. I don't know why I put H2. Okay, so H1. Then volume 2 is going to equal 1/3 pi times its radius, which is 6 squared. But the height's not the same. It's height 2. But these are equal. So because they're equal, we can divide out the 1/3 pi on both. It doesn't play a role. This is going to be 9h1 equals 36h2. So I can divide by 9 to get that the first height is 4 times the second height. Okay, now, did they tell us what the volume was of the liquid? No. So guess what that means? We can make it whatever we want because we're looking ultimately for a ratio. I'm going to see it in a minute. What is the ratio of the rise of the liquid level in the narrow cone to the rise? Okay, we'll get there in a moment. But short summary, we can make H2 1. So this height right here, I'm going to make it 1, and then this height here would be 4. It doesn't matter what it actually is because it's all going to wash out in the ratio in the end. And because they didn't tell us the volume of the liquid anyway. So any volume would have to work, otherwise the problem would be invalid. Okay, so where were we? Into each cone is dropped a spherical marble of radius 1, okay, which sinks to the bottom and is completely submerged without spilling any liquid. What is the ratio of the rise of the liquid, right? You drop something into water, the water level rises. They want the ratio of the rise of the liquid level in the narrow cone, this one, to the rise of the liquid level in the wide cone. Well, it's probably not too uncommon knowledge that the volume of the stone or marble that you put inside is what's added to the volume of the water now, the apparent volume of the water, right? And so our previous volume, now that we've assumed the height is 4, our volume 1 will be 1/3 pi times 3 squared times 4. Or it would be 9/3 is 3 times 4 is 12 pi. Okay, so 12 pi is our volume 1. And to that volume, we're going to add a marble with radius 1. Now the volume of a sphere, which is what a marble is 4/3 pi r cubed. Take the derivative of that. Tell me what you get. Anyhow, moving on, 4/3 pi r cubed, and you're going to plug in 1 to this because it's the radius of the marble. That means the marble's volume is 4/3 pi. We're going to combine that with the 12 pi. So I've got 12 pi plus 4/3 pi. Let's make this into something over 3. 36/3 plus 4/3 will be 40/3 pi. Now, this is the volume, the apparent volume that the water is taking up now when you add the marble to it. So it's going to have a new height. And we can take the new height, subtract the old height, that will be the rise. So then, let's set this equal to a cone's volume again. It's 1/3 pi. Interesting. 1/3 pi r squared h. Yeah. 1/3 pi r squared h. And so why is the r not 3 anymore? Because it went up. And when it went up, the surface of the water went up higher, so the radius is now different than what it was. So what we would have is that whatever the radius is, it's 3/4 of the height. So I could make this radius here will be 3/4 of the new height. And so that's going to be 3/4 h squared times that height. So the pi's will cancel, the 3's will cancel. I'm going to get 40 equals 9/16 h cubed. I will then multiply by 16/9 times 40 equals h cubed. And we need to find out what the new height is and then subtract 4. So I need the cube root of this. Yeah, kind of not fun. Let's see. So we're going to have 16 times 4 is 64 times 10/9. I'm going to keep the 64 separate, so when we cube root, we're going to have 4 cube root of 10 ninths. So it's 4 cube root of 10 over 9. Don't bother rationalizing anything, it doesn't really matter. From that, we are going to subtract 4 cube root of 10 ninths minus the 4 original height that we had. So we subtract 4. This is the rise in the water level, okay? And then, oh, it's 3/4 of the height. Yeah, we did that right. Okay, so it was 9/16. We multiplied by the reciprocal, just making sure. Okay, so then this is the rise in the first one's height. Now, the second one's height, it's going to be the volume 2. It also had the same volume, actually, right? And so when you added the marble, it's the exact same new volume, if you will. So it's 40 over 3 pi as well. And you're going to have 40 over 3 pi, and it's going to equal 1/3 pi r squared h. But again, our r this time is a 6:1 ratio with the height. So we're actually going to have to replace this r with 6 times the new height, whatever the new height is. So 6 times the new height squared times h. Again, that's just the r squared h, where we see the ratio of 6:1 is the radius to the height. It's going to maintain that ratio throughout because of similar triangles. So this h over here, you can call it h2 if you want. I suppose we don't really need to because it's fine though. If you want to call it h2, no problem. Okay, so now we'll solve for h2. We're going to get rid of the 1/3 and the pi. Again, we're going to divide by 36. So we're going to get 40 over 36 is equal to h cubed, h2 cubed. Okay, then what? 40 over 36, we have to cube root that. So we have to cube root it, and then we have to subtract 4. So we're going to have the cube root of, let's do this, simplify this. 40 over 36 is 10 over 9, right? So you have the cube root of 10 over 9 minus the original height, which was 1. So cube root of 10 over 9 minus 1. And now you're going to put that here. I'm running out of board space, but let's just erase this and use this spot right here. So if I divide, it's going to be cube root of 10 over 9 minus 1. And now you will factor out the 4, and it will cancel the cube root of 10 over 9 minus 1 over the cube root of 10 over 9 minus 1. The ratio you get is 4:1. Now we know this is the narrow cone because that's the one that we used first. So we get a 4:1 answer. Answer choice E. Quite a difficult problem. It's really starting to get hard on the AMC 10 and the AMC 12. We're getting close to qualifying. That's probably why. On to the next problem. All right, and up next we've got the 2021 AMC 10A problem 13. If you've been watching my channel, there was a video that came out recently. I did the 2015 AMC 10A problem. I think it was 21. Let me just double check that. Yeah, problem 21 from AMC 10A. It was the 12A problem 16. And so if you've been watching that, that lends directly into this problem. In fact, wishful thinking gets me this answer really quickly. And if you watch that, hopefully it did it for you as well. What is the volume of tetrahedron ABCD? If you haven't seen that video, pause this one maybe, go watch that one, and then come back and see if you can see what we're about to do, how quickly it comes together. So the volume of tetrahedron ABCD with all of these edge lengths. I'm not going to lie, it's exactly what I did when I was solving it. Solving it not officially, but just on my own, solving the problems. Exactly what I did was I looked for something that would make it 3, 4, 5. I've got A, C, A, D, and C, D. Those are 3 of the same letters, A, C, and D. So I start by drawing that. I guess, how should we draw this? Let's go here, and here, and here. Okay, so we've got AC is 3, AD is 4. A is at the mid of those two. So this will be AC, AD will be here, 4 and 3 and 5 CD. Why do I want that? Because I'm looking for a right triangle. That's what I expect after having my experience on the previous problem. I'm hopeful that it will materialize. Furthermore, I'm hopeful that the other side, B, will be basically at a 90-degree angle to this plane. So if I put B here, what are the other lengths? We've got AB is 2, that's this length here. We've got BD is 2 root 5, that's this length here. And already 2, 4, 2 root 5. That's a right triangle. So how does that work? If you do a right triangle that's 1 to 2, if you do that very often, you know the hypotenuse is root 5. Double 1 to get 2, double 2 to get 4, double root 5 to get 2 root 5. So we do know right now that BA is perpendicular to AD, but we don't yet know it's perpendicular to the plane. It could still be perpendicular to that, but at an angle, so we're going to need another thing to help. It needs to be this triangle. BC is root 13. Okay, so root 13, I've got 2 and 3. If you do Pythagorean on that, 2 squared plus 3 squared is 13. That means that AB is also perpendicular to AC. And since these two are perpendicular to each other, meaning AD and AC, the only way that can happen is if AB is coming directly off the board at a 90-degree angle to the plane. And what that means is that this 2 is the height of the tetrahedron. This worked exactly like, or a lot like at least, the other question, the other test that we did. So 2 then here is going to be the 1/3 area of the base times the height. So the area of this base is 3 times 4 is 12, over 2 is 6. So we're going to have 1/3 times 6 times the height of 2. 1/3 of 6 is 2. 2 times 2 is 4. Again, this is why you want to solve all the past tests. All of them. Do them all. They're not even enough. You need to solve more than that. Thousands, hundreds, lots of problem solving. Get all of it in. Your experience will help you to see things on the test. So if you didn't follow that, we proved that AB is perpendicular to AC and AD. And the only way that can happen is if it's straight up. Okay, so that's it. On to the next one. Here we go. And here we go on the 2021 AMC 10A problem 14, also the 12A problem 12. All the roots of polynomial, looks like this, are positive integers, possibly repeated, possibly, right? We know what that means, definitely repeated, most likely. What is the value of B, this coefficient right here? Now the first thing is I don't like Z, I don't like S either. I usually change those variables to X most of the time. So that's what I'm going to do here. But what I want to think about first is these roots. Polynomials to 6th degree have 6 roots. They could be repeated still, but they still have 6 roots, right? So then what are we looking at? Why do they give us this one and this one, but all the rest are variables? Well, probably because you're supposed to use Vietta's formulas. And this is the coefficient that you need to get the sum of the roots. The sum of the roots for every polynomial is always the negative second coefficient over the first. So we know R1 plus R2 plus R3 plus R4 plus R5 plus R6 is equal to 10. And what about this one down here? Well, that's how you get the product of the roots. The product of the roots is always this, the constant, over the leading coefficient. If it's an even degreed polynomial, it will be just that number over this, meaning it's 16 over 1. If it's an odd degree polynomial, like say it had been z to the 5th, then it would be the negative version of this over 1. Look up Vietta's formulas to learn more about those. There are a few more powerful tools in there, especially for cubics, like pairwise product of roots and stuff like that. So R1 plus all this, we also know R1 times R2 times R3 times R4 times R5, and finally our 6 is 16. Now, I happen to know 16 is 2 to the 4th. I also know we've got a lot of positive integers that have to add up to 10. So probably, if it's going to work out, it probably a lot of 2's in here, right? So it'd be 2, 2, 2, 2. What would we have left? They'd have to be 1's, wouldn't they? Let's see. 1, 1, 2, 2, 2, and 2. Would these add up to 10? Well, I'll let you check. 8 plus 2 is 10. They definitely do, so these are the roots. So we now know we can write this. Again, I'm changing to x for my own reasons. And then x minus 2 to the 4th. That's what this polynomial represents. And so we want to know what the b value is. Well, the b value is the coefficient of z cubed. We could expand all this using binomial expansion, but maybe there's a faster way. Why are these both even? Maybe so that you can take out a power of 2, and then it would look like this. And this would be a cubic, and maybe we could think about it faster if we just attacked this. So x squared minus 4x plus 4 times x minus 1. We're going to just ignore the squared for right now. Distribute this x to everything. X cubed minus 4x squared plus 4x. Now distribute the negative 1. Line up your terms. Negative 1 times negative 4 is positive 4x, and then minus 4. So that expression, once gathered like terms or combined like terms, is x cubed minus 5x squared plus 8x minus 4, and then this is all being squared. And this generates that. Obviously the x's convert to z's, as we talked about. So I want the coefficient of the x cubed term. We could expand it. You could do that if you want. If you did it on your paper, that's fine. But I'm just going to think about how x cubes get created. I'm going to have to multiply this with one of these terms. It's not that one, it's that one. So I'm going to definitely get a negative 4x cubed because it's 2 of these side by side, right? So I'm multiplying this times all 4 of these, but the ones that create the x cubes are the x cubed in this one. Then when I distribute this term, right, because again, it's 2 of these side by side. So now you're distributing this negative 5x squared to all of those, right? And so if you multiply it, again, which one would it have to multiply with? It'd have to multiply with this one, and that's going to give you your negative 40x cubed. Furthermore, when we get to this one, it will have to go with that one, which is also going to be negative 40x cubed. And then when we get to this one, it will have to multiply. So you're basically at the end of this term, multiplying it with the first one here to get another negative 4x cubed, negative 88. Answer choice A. Let's get on with it. All right, and now for the 2021 AMC 10A problem 15, the last one of this rapid fire set. Values for A, B, C, and D are to be selected from that set without replacement, i.e. no letters have the same value. How many ways are there to make such choices so that the two curves ax squared plus b and cx squared plus d intersect? It says the order in which the curves are listed does not matter. For example, if you had 3x squared plus 2 and 4x squared plus 1, or you switched it, where this became 3x squared plus 2 and that one became 4x squared plus 1, those are considered the same, okay? So what do we do? If they're going to intersect, right, then you probably should set them equal, because setting them equal will tell you where the x values of the points of intersection are. Right, so then I'm probably going to want to get the x terms together, so I'll move this over. I'm going to factor out the x squared. A minus cx squared. Let's get the b away from the x's. So it's going to be equal to d minus b, and now we will divide, and I think we found some kind of significant conclusion. We just have to analyze what we've got. Well, this is something squared. It needs to be a real number for them to intersect. It will only be real. First off, A cannot equal C. That would make it 0, but it already can't equal C because the two letters can't have the same value. We don't have to worry about D equaling B for the same reason. So basically, if these are both positive, meaning that D is greater than B and A is greater than C, If both of those are true, you would have a positive number here, which would have a real solution. Okay. What about if they are both negative? I could have another case where D is less than B and C is less than A. So we'll try to think about these two things. I'm sorry, A is less than C. I said the same thing, right? So A less than C. So if A was less than C, I would have a negative over a negative, which becomes a positive. You see how that goes. All right, let's start with this. D greater than B. Well, they have to be unique choices. So if D is going to be greater than B, it should be any selection of 2 is possible. So I could do 6 choose 2. Okay, so if I do 6 choose 2, that's going to be 15. You should memorize your first several choose 2s. They come up a lot. Okay, so then 6 choose 2 is 15. Also, you can use n times n minus 1 over 2. So 6 times 5 is 30 over 2 is 15. If you don't know why that works, investigate it. Prove it to yourself. Okay. A greater than C, we don't have access to the 2 numbers that I chose for D and B. There's only 4 numbers remaining. I would need to choose 2 of them, and there's 6 ways to do that. Now, once I've chosen the 2 numbers, say I choose 3 and 5, do I really get a choice for which one's which? No, I need D in this case right here. We're doing the top case, case 1 if you will. I need D to be greater than B. There's only one way to do that. 5 has to be bigger than 3, so 5 would be D and B would be 3. Okay, so that's how that would work, and these are the same result. They're going to have to be that they don't get to choose which ones they are as long as we're doing the D greater than B and A greater than C. There's only one way to assign them once they're chosen. Therefore, if I do 15 times 6, that's going to give me 90 ways. Now, we have to be careful because we're in the danger zone here. What about this one over here? This would be another case, and if I did it, same kind of reasoning, that would be 180, and that would be wrong. And the reason that it's wrong is because all of the ways that C is greater than A and B, what are C and A? C and A are these 2 values, coefficients of x squared, and D and B are the constants. So every single way where, like, let's just do a scenario. If I was to count, like this one right here, right? We've got D equals 5, B equals 3. And let's say the other 2 terms were 4 and 1. Then A would have been 4 and C would have been 1. Okay, for this choice of 4 and 1 from the remaining numbers. These are just randomly assigned to investigate, basically. So what's going to happen is if I switch it to the other one, and when I do the D less than B and I choose the numbers, now it would be that B is 5 and D is 3 if they chose the first 2 numbers. And that would be one of the ways that works out. And if I chose 4 and 1 for A and C, but C is greater, now C would be 4 and A would be 1. Okay, so if we compare, what is it? I've got 1 x squared plus 5. X squared plus 5 on this side. I've got 4x squared plus 3 on the other. So x squared plus 5, 4x squared plus 3. Okay, but what about this one over here? It's going to give me 4x squared plus 1, or plus 3 rather. 4x squared plus 3 for this term. And the other one's going to be 5 or 1x squared plus 5. They're just the 2 things we had switched, which is precisely what it says is considered the same. So every single one of the ways that would have worked out here, we've already got it on this side. Therefore, 90, C, is the final answer. See you guys in the next set of 5. Don't forget to turn on notifications. If you like this kind of content, feel free to subscribe. See you guys around.